Take a look at this question on your screen from the Stanford Math Tournament in 2022, just a few years ago. We're given x, y, and z, they're real numbers, and their product is 10 right over here. And we're asked to find the maximum possible value of this over here. So it's x cubed, y cubed, z cubed, which isn't too bad to work with, you'll see. And then minus 3, and then this part over here looks pretty difficult to work with. Right, it's 3x to the minus 3x to the fourth plus 12y squared plus 12z to the fourth. So the exponents aren't the same either. So there might be some weird stuff going on over there, but we'll find out. Now, the first thing to notice is, and hopefully you've already seen this, but if x, y, z is 10, x cubed, y cubed, z cubed, so I'm just going to write this here, x cubed, y cubed, z cubed is just equal to x, y, z whole cube, right? And that's just 10 cubed, which is 1,000. So we know that it's 1,000 over here. And so we can rewrite this as 1,000. And now I'm going to do a little bit more. I notice that there's minus, 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 and then 3, 12, and 12 are all factors of 3. So, all multiples of 3. So I'm just going to take out a 3 over here. And now I'm left with, pause the video and work through this on your own, x to the fourth plus 4y squared plus z to the fourth, 4z to the fourth. One sec. Okay, so just check my algebra here. I mean, yeah, you can't, it's not live, so you can't tell me, but hopefully I don't make any mistakes here. Maybe I will. If I do, just correct me in the comments, okay? Maybe I'll make the mistakes intentionally so that you have a little more to do as well. Anyway, now think about this, right? If we want the maximum possible value of this, we want to minimize this, right? Because then we're subtracting a smaller number. So we want the minimum value of this. Now, the only piece of information we have about x, y, and z is that they're real, okay, fine, and that their product is x, y, z equals 10. Now that can mean a lot of things. That doesn't tell us that they're positive, for example, right? X could be -5, y could be -2, z could be 1. But we do know that they're either all positive or 2 of them are negative and 1 of them is positive, just so that the signs match up and we get positive 10. But that, we're not going to sit here and guess around at the different values, right? So what else can we do? Well, notice one thing. We have x to the fourth, that's an even power, y squared, that's another even power, z to the fourth is another even power. So maybe we can do something over there. And one thing, and if it's an even power, of course, these have to be greater than 0, right? Well, okay, if it's an even power, that means that the value will be greater than or equal to 0. However, we know that none of them can actually be 0 because then x, y, z would be 0. So we know that they're all strictly greater than 0. And now that we've got this, we know we have one condition. We're asked to find the maximum value or the minimum value of a sum, and we know that they're all positive. We can now actually use the AMGM inequality, okay? And the reason, and I mean, I can't really explain exactly why it's the best thing to do over here. You'll see how it works out, and the more familiarity you get, the more your pattern recognition skills will improve. Now, before we actually use that though, if you've made it this far, please make sure to subscribe, okay? It'll really help me out, and you can stay tuned for more of these sorts of videos. And assuming that you subscribe, I'm going to switch to blue now, so there's a nice, a little bit of extra color over here. Now the thing is, I'll quickly show you how the AMGM inequality works. It basically says a plus b over 2 is greater than or equal to, oh wait. Yeah, it's greater than or equal to the square root of AB, and you can extend this, right? Over here, of course, they're not just 2 terms, they're more than 2 terms. But yeah, so you can extend this to 3 terms, and all that you'll change is a plus b plus c over 3 is greater than or equal to the cube root of ABC. So essentially it states that the arithmetic mean is greater than the geometric mean, right? AM, arithmetic mean, is greater than or equal to the geometric mean. Okay, hopefully the bottom lines don't confuse you too much. I'm having a lot of faux pas today, but anyway, let's continue here. Now, what we want over here though is, of course, on the right hand side, we want, okay, so first of all, it's not A, B, and C, it's X, Y, and Z, but that's easy enough to fix. But if we plug this in right now, we'll have x to the fourth plus 4y squared plus 4z to the fourth over 3 is greater than or equal to the cube root of, okay, and this is clearly not going to work, right? X to the fourth times 4y squared times 4z to the fourth. And you might think, oh, this is just a trap. Let's just go plug in values and maybe it'll be a convenient little pair. But don't give up because we're almost there, right? We're very, very close. And this is the trick over here, right? I never said that you can't change A, B, or C, right? You can write B as 1/2 B plus 1/2 B, then this will become a 4, this will become a 4, over here, and then this will become 1/2 b times 1/2 b. So let's do the same thing over here. And I already gave you the hint. Instead of 1/2 b, we just do 1/2 of 4y squared. The reason for this is that if we split it into two terms, they're now going to be 4 terms. So we get a fourth, the index over here becomes 4, which is perfect for us because we've got x to the fourth and z to the fourth. And the best part is that this is now going to become 2y squared plus 2y squared, which is still 4y squared. But when you multiply them, you get 4 times y squared, which is y to the fourth. So now we've got 4, 4, 4, and that comes out perfectly, right? So we're completely good now. This is all we have to do. Let's put this in. Let's see what we get. We have x to the fourth plus 2y squared plus 2y squared again plus 4z to the fourth. Exact same thing as what we had. We haven't changed anything. And then we have to divide by, don't mess up over here. This would be a bad place to mess up, but it's going to be 4, right? And this is greater than or equal to the fourth root of whatever comes up here. Now what's going to come up here? It's the product of all of these. So that's x to the fourth, y to the fourth, z to the fourth. So x, y, z to the fourth. And this is just a nice little coincidence, but it's 2 times 2 times 2 squared. So that's also 2 to the fourth. Works out beautifully, right? On the left hand side, we now have, so I'm going to multiply both sides by 4, which is allowed. 4y squared plus 4z to the fourth. That's a 4 right there. It's greater than or equal to 4 times, well, what's this going to be? It's going to be the magnitude of xyz, but we know that that's already 10, right? That's given in the problem, times 2. And so what's that? That's 80, right? So x to the fourth plus 4y squared plus 4z to the fourth is always greater than or equal to 80. Now this is for you, right? This is a question for you. When does equality hold? And if you aren't too familiar with the AMGM inequality, pause the video, try this out for yourself, comment below what you think, and if you need some help, maybe start off with this, okay, and square both sides and see if you can figure it out from there. That's your hint over here. And I'll give you a hint, I'll give you another hint. Once you do it for the smaller case, it's the same basic idea for the generalization as well. Okay, so that's a question for you. Work on that if you want. But anyway, let's finish off the question. Now, if this is the case, if it's greater than or equal to 80, obviously the minimum value is 80, right? It's never going to be less than 80. So all we have to do is now plug that in over here. We have 1000 minus 3 times 80, which is 1000 minus 240. And I'm going to let you do the honors of finishing it off. Pause the video. And yeah, that's 760 right over there. And with that, we're done. So that's it. That's our final answer. This is question 5, so it's pretty far along in the Stanford Math Tournament. And, you know, just from my own experience, I think if you're able to get 5 or 6, that should be enough for an honorable mention. So yeah, hopefully this video helped you. Okay, it's not super difficult, and it's also pretty recent. It's only from 2022, so it's not, you know, oh, an absurdly easy question or anything like that. It's a good question. Hopefully, now the key idea, right? I just want to break it down a little bit. Don't give up when you see something that's close to the AMGM inequality or close to something that you want. See if you can manipulate it. Like, look at how well this little manipulation turned out for us, right? With this, we were able to get 16, which is perfect. We were able to, well, we would have had 16. No, if we did 1 and 3, we wouldn't have had 16, right? But actually, that's kind of interesting. What would have happened if we did 1y squared plus 3y squared? Because that's also a legitimate way of doing it, right? Okay, okay, now I'm a little curious. Let me, anyway, yeah, the idea is I just keep going and see what happens, and you should be, and you'll be good to go. Yeah, anyway, that's it for this video. Hopefully that makes sense. Now, okay, now I am a little curious. Instead of writing 4y squared as 2y squared plus 2y squared, what would have happened if we did 1y squared, or just y squared plus 3y squared? Okay, comment that down below. I'm excited to see your responses and what you have to say about it. But yeah, that's it for this video. It's almost approaching 10 minutes. I don't want to take too much of your time. But yeah, that's it. Thank you so much for watching. Again, if you're still here, please make sure to subscribe. It'll help me out a lot. And I'll see you in the next video. Bye-bye.